Yes, welcome to Vision Plus. Today we are looking at questions on the revision section, and the question we have received is that prove that sine of 3a equals to 3 sine a minus 4 sine cube a. So, and this is going to be the solution. When we are solving this, um, we shall say sine of 3a equals to. So we are going to divide this into a double angle so that this 3 is into two angles that make no change. Example, you can say sine of 2a plus a. Now by this we have not changed the meaning of sine 3a. Why? Because 2a plus a still gives us 3a. So now we have just looked at some tan proof, and we have seen that there is this formula. Let me put it as NB, that if you have sine of two angles, A minus A plus or minus B, this gives us, now for the first part, 1, if it is a plus, like sine of A plus B, we have said that this gives us sine of A cos of B plus cos of A sine of B. 2 is for the minus part, sine of A minus B. This gives us sine of A cos of B minus cos of A sine of B. These are the two formulas that we know the whole. So if you look at it, ours corresponds to this first one of sine A plus sine B, whereby A in this case, A is any angle. So this A in this case, it will correspond to our 2A. And the other half angle, B, will correspond to our angle here, A. That means if we are to apply this principle, we shall therefore say sine of 3A, I'll put the brackets, but there's no problem with that, equals to, now we're going to equals to, let me first copy that, sine of 2A plus A. So we're going to expand this. So this is the first angle. So we shall say sine of the first angle A, which is in this case it is 2A, and then cosine of the second angle, like for this case it was B, it corresponds to A here, cosine of A, and then we're going to say plus cos of the first angle. Now this first angle here, like in this case it was A, so here it is A, but our first angle here is 2A, so we shall put here cosine of 2A, and then we put sine of the second angle A. You just do not repeat. If you have used 2A already, that means the second one of sine should have A. But for cos, it was A, that means the second term should contain 2A. So after this, we have applied this formula principle. Now, if you look at our proof, we have sine of A and sine cube A. These are the coefficients, and we shall see them. So we shall try to find a way that all our terms are in terms of sine. So that means here I will start by, you know that sine of 2A, sine of 2A, this is the same as 2 sine of A cos of A. Yes, that is an identity, and you should find time and try to understand that. So we shall substitute here that instead of sine 2A, sine 2 is the same as 2 sine of A cos of A. And then we have this other cos of A, cos of A. it is only sine 2a that is the same as 2 sine a cos a. But there is this other cos a. And then plus. Also, since we have a sine here, it is okay. But here we have a cosine. So there are two identities for cos of 2a. The first one is the same as 1 minus 2 sine square of a, or cosine of 2a is the same as 2 cos squared a minus 1. In your discussions, please be in position to revise that. That means, since we are going away from cosine, this second identity here gives us cos square a. But if you look at our proof, we all have sine, so we shall take this one that has sine. So instead of cos 2a, we shall have 1 minus 2 sine squared of a. This is just the position of cos of 2a. Cos of 2 is the same as 1 minus 2 sine square a. And then there is also this sine a attached to it, so we are multiplying it here by sine of a. Now let's simplify. Now on simplifying, this would actually take a white space, but let me clear here so that we're not limited. So let me just copy this left hand side. So sine of 3a equals to, I'm picking up from here. So I'm going to open the bracket because this is a multiplication. This one is single term. Times that. So if you have 2 sine a cos a times cos a, these are like terms and they're going to multiply. So it will give us 2 sine of a cos square of a. Cos a times cos a gives us cos square a. Plus, we are going to shift this sign to multiply all the terms. Like inside here, there are two terms. The first term is 1, and the second term is negative 2 sine square a. So sine of a is going to multiply all the terms in the bracket. So sine a times 1 gives us sine a. Sine a times 1, it gives us sine a. Minus, since it is a minus here, sine a times sine square a. Here you're multiplying sine of a times sine squared a. Now, these are the same basis. These are terms of the same basis. So we simply add the power. So sine a times sine square a gives us sine cube a. Yes, sine a times sine square a gives us sine cubed a. That is just by laws of indices. You just add the powers. So this 2 is just a constant. So 2 sine cubed of a. Okay, our space has been given. Is good. Yes. Now we have simplified. So let's continue to further simplify until we reach there. Now here you have cosine square a, but if you look at our term here, we don't have that. So we know that we shall have 2 sine a, and we know that what is cos square a? That is that identity that says sine square a plus cos square a equals to 1. So if we make this the subject of the formula, we shall take sine square a that side. That gives us cos square a equals to 1 minus sine squared a. So we substitute there 1 minus sine squared a. This is the same as cos squared a plus, let me now get rid of the brackets, not guarding anything. This sine a minus 2 sine cube of a. Let us open this bracket by multiplying 2 sine a times 1. It gives us 2 sine a still. The number times 1 itself. minus 2 sine A times sine square A. First of all, 2 is a constant. Yes, 2 is a constant. So sine of A times sine square A, it gives us sine cubed A. Then proceed. Sine of A minus 2 sine cube A. Now let us collect the like terms. Those ones that have the same powers, we shall group them together. Those ones that have the same powers of 1 anyway, we shall group them. That means we shall have 2, these are like term. 2 sine A is a like term to sine A, but its sign is plus. So we shall say plus sine of A. We shall say plus sine of A. And then you pick up from here, we shall say minus 2 sine cube A. Also this one is a minus. It's negative minus 2 sine cubed A. Then we continue. What is 2 sine A plus sine A? It is simply 3 sine of A. It's just like saying what is 2A plus A? It is 3A. Or simply what is 2B plus B? It is 3B. So 2 sine A plus sine A is 3 sine A. Now we are going to try to add this. This one is negative and this one is negative. So sine cube A is common. So if you are subtracting negative 2 sine cube A minus 2 sine cube A to give us negative 4 sine cubed A. And we pause a bit and we look at it. That is what we are trying to prove. So this one really calls for a lot of concepts. Like you must be able to know maybe the laws of multiplication of these trig ratios and what identity is sine of 2A giving us. What are the two identities or the results of cos of 2A? And then this is actually the first identity, that sine square A plus cos square A gives us 1. As long as the square is square, it gives us 1. And the angles are also maintained as the same. And then from here you can be able to change. If you are looking for sine square A, then you take cos square A that side and subtract. But if you are looking for cos square A, that means you take sine that side and then you subtract. You just follow the laws of crossing the equal sign of linear equation. So therefore, this is the proof that sine of 3A is actually the same as 3 sine A minus 4 sine cubed A. Please, if you have questions that you need us to address, send them to our official WhatsApp group, or you can leave a comment stating that question, and we shall be able to attend to it. Thank you.